November 7th, 1940. Puget Sound, Washington State, 7:30 in the morning. A man named Leonard Coatsworth drives his car onto a suspension bridge. The bridge is 4 months old. It cost $6.4 million. It was designed to last a century. By 11 o'clock, he will be running for his life. His car, still on the bridge, will be gone. His dog, still inside the car, will be gone. The bridge itself, all 5,900 feet of it, will have vanished into the cold gray water of Puget Sound. Not because of an earthquake, not because of a structural flaw anyone could see with their eyes, because of wind, an ordinary November wind, 40 miles an hour, the kind of wind that knocks over an umbrella. What happened to the Tacoma Narrows Bridge didn't just kill a structure, it exposed something terrifying about the limits of human knowledge. This is the story of a bridge that should not have collapsed, and the man who should have known it would. To understand why the Tacoma Narrows Bridge existed, you need to understand what it replaced. On the eastern side, Tacoma, a working industrial port, the 7th largest city in the American West. Between them, a crossing that could take 45 minutes on a good day. The ferry service was overloaded, unreliable, and expensive. Workers were losing hours they couldn't afford to lose. The state of Washington had been fighting for a bridge since the 1920s. The problem was not will. The problem was money. In 1938, the money arrived in the form of a Federal Public Works Administration loan worth $2.7 million. Clark Eldridge was the Washington State Highway Department engineer assigned to design the bridge. His plan was conservative, proven, solid, a design that could handle the wind. Leon Moisseiff had worked on the Manhattan Bridge, the Golden Gate Bridge, the George Washington Bridge. He was the man America called when it needed someone brilliant. Moisseiff looked at Eldridge's plans and said, "Too heavy, too expensive, too much." The new design was elegant. 8 feet of solid plate girder along each side. The ratio of depth to span was the most extreme ever attempted on a major suspension bridge. Eldridge signed off because he had to. He did not agree. Construction began in November 1938. The site was not forgiving. Winds come off the Pacific, compress through the narrow channel, and accelerate. The tidal currents run at nearly 13 miles per hour and reverse direction 4 times a day. First came the piers. Workers lowered hollow steel caissons into the Narrows and kept adding weight until the cutting edges touched bottom. Then kept going, boring down through sand and silt until the East Pier had penetrated 230 feet below the surface of Puget Sound. The work alone took 9 months. Then the towers, 2 of them, rising 425 feet above the water. Workers rode traveler derricks up the growing steel columns in the November cold, the wind off the Sound hitting them at height with nothing between it and them. Then the cables. Temporary catwalks were strung the full length of the span, narrow mesh walkways swaying 200 feet above the water. A spinning wheel carried a single wire from one anchorage to the other and back. Workers on the catwalks guided each one into position. That wheel crossed the Narrows thousands of times until each cable held enough wires to be squeezed into a solid bundle 17.5 inches across. Workers tiny against machines. Night shifts in the January cold. The brutal, invisible work. As they began laying the deck, bolting sections into place from the center of the span outward, the bridge moved. They called it Galloping Gertie. It was, at first, a joke.
He just turned red and walked away.
The bridge was telling anyone who knew how to listen exactly what was going to happen. Nobody knew how to listen. The state hired a professor from the University of Washington to study it. He measured the oscillations. He wrote a report. The report said the bridge was safe. On July 1st, 1940, ahead of the original estimate, the Tacoma Narrows Bridge officially opened to traffic. Opening day drew crowds. People had waited years for this. The line of cars stretched back through Tacoma. Then the cars got on the bridge, and immediately some of them pulled over. Not because they were scared, because it was extraordinary. You could feel the deck shifting beneath your tires. A long, rolling motion, like crossing a wave. Some people drove across Galloping Gertie specifically to feel it. Families would drive out on weekends to experience the bridge the way you might experience a carnival ride. Moissaieff published a paper defending his design. The oscillations were within acceptable limits. He was aware. He was not worried. State engineers tried cables to anchor the bridge deck to the seabed. They added more hydraulic buffers. Nothing made a significant difference. Clark Eldridge watched from a distance. He did not say, "I told you so." He did not need to. What nobody understood yet was that Galloping Gertie was not just moving, it was communicating. Every oscillation, every wave, every shudder was the bridge announcing the terms of its own destruction. It had been doing it since the first day it opened. Thursday, November 7th, 1940. The bridge is 4 months and 6 days old. At 7:30 in the morning, the wind is 40 miles per hour. This is not a storm. Leonard Coatsworth is a news editor for the Tacoma News-Tribune. He drives onto the bridge at approximately 7:45. He has crossed it many times. He is not worried. Within minutes, everything changes. The bridge's motion shifts from its familiar vertical undulation to something new, something nobody had seen before. It begins to twist, to rotate on its longitudinal axis. The eastern edge of the roadway rises while the western edge falls. Then they switch. Coatsworth's car slides. He fights the wheel. The grade beneath him is now so steep that his car cannot move forward. He opens the door and falls, not onto flat road, onto a surface tilted almost 45 degrees. He crawls, literally crawls, on his hands and knees, gripping the concrete curb 250 feet above the water. For 500 feet he crawls before he reaches the tower. Coatsworth turns back once, sees the bridge moving, cannot go back. Barney Elliott, the local camera shop owner, has driven to the bridge with a 16mm camera. What he captures becomes perhaps the most important engineering film ever recorded. Then the bridge begins to come apart. Chunks of concrete break free from the roadway and fall. Not crumbling, breaking, slamming into the sound 190 feet below like artillery. Witnesses on the shore describe the sound as popcorn. Then the suspender cables begin to go. Each one snaps with a sound like a rifle shot, a single sharp crack carrying across the Narrows. The broken cables whip upward and hang loose, swinging above the churning water below. The steel plate girders begin to twist along their entire length. Massive sections of steel, ringing on their own axis like rubber. Bolts shear and spin into the air. At 10:55 in the morning, the first section of the main span breaks free. The sound, witnesses say, is unlike anything they have heard. A 600-foot section of roadway wrenches from its cables in a cloud of concrete dust, flips over in the air, and plunges 195 feet into Puget Sound. A geyser of foam shoots upward over 100 feet. Tubby the dog, still in Leonard Coatsworth's car on the bridge, goes with them. At 11:02 a.m. on November 7th, 1940, the main span of the Tacoma Narrows Bridge hits the water. The water settles. The towers stand, still anchored to their piers, connected to nothing. The cables hang loose in the November air. The bridge is gone. All 5,939 feet of it. $6.4 million. 2 years of construction. 17,000 tons of concrete and steel. Leonard Coatsworth submits an invoice to the state of Washington for the value of his car. He is reimbursed. His dog is not replaceable, so there is no line on the form for that. Leon Moissaieff receives the news in New York. He will never design another bridge. The investigation that followed the collapse changed everything. Theodore von Karman led the analysis. What he found rewrote the textbooks. The solid plate girders acted like a wing. The deck began to move, and as it moved, it altered the airflow in a way that made it move more. Civil engineers and aerospace engineers did not talk to each other in 1940. They had different journals, different conferences, different assumptions. The Bronx Whitestone Bridge in New York was retrofitted almost immediately. Its solid plate girders were replaced with open trusses. Wind tunnel testing became mandatory, not optional, not recommended, mandatory. Every major suspension bridge built since 1940, the Humber Bridge, the Millau Viaduct, the Akashi Kaikyo, was wind tunnel tested before a single tower was built. Everyone, because of Galloping Gertie, because of a dog named Tubby, and a news editor who crawled across a twisting bridge on his hands and knees. The bridge was built to last 100 years. It lasted 4 months, and it saved more lives in its death than it ever could have in a century of standing. The Tacoma Narrows wreck was listed on the National Register of Historic Places in 1992. It remains one of the world's most significant artificial reef dive sites.